As we have finished exercise 9.1, we need to jump to exercise 9.2. Very easiest sum. We have only 2 sums in this exercise, but we have 3 to 4 sums in the examples. If you easily understand the first 2 sums in the exercise, then the remaining sums in the examples is very going to be easy for you. So before entering inside the exercise 9.2, first we see the formulas. The first formula, limit formulas to evaluate, to find the values. First formula, limit a to b, integration of a to b, upper limit, lower limit, f of x and dx, limit n tends to infinity. This n tends to infinity. This infinity we can write as 1 by 0 also. This infinity we can write as 1 by 0. Infinity we can write as 1 by 0. So limit n tends to infinity, b minus a by n. Now only we have studied in exercise 9.1, b minus a by n is nothing but h is equal to delta x, nothing but with sigma r equal to 1 to n. We can say summation also, we can say sigma also. Sigma r equal to 1 to n, f of a plus, once again f of a plus b minus a by n. So once again the same b minus a by n into r. If we are going to memorize this formula, then the sums which are going to derive in this exercise is going to be very easy for you. Next, this sigma r equal to 1 to n, or you can say summation of r equal to 1 to n is with any constant. Then you can multiply n into constant. Suppose I am going to take 3. In spite the 3 is one of the constant. No, if we are going to take 3, summation of r equal to 1 to n, 3 we can write as 3n. Suppose if I am going to take 4, you can write as 4n, constant into n, that's all, 4n. If there is going to be a constant in sigma, if there is constant is present, I can multiply 3 into n, otherwise 4 into n. Sigma r equal to 1 to n r. The formula is nothing but n into n plus 1 by 2, because n is present, no, here r. This is called, this formula you study in 10th standard also, n into n plus 1 by 2, n into n plus 1, 2n plus 1 by 6, n into n plus 1 by 2 the whole square. If it is r square and r cube, r square and r cube, because here n is present, so n into n plus 1 by 2, n is present, n into n plus 1, 2n plus 1 by 6, n is present, n into n plus 1 by 2 the whole cube. This is a formula. So this is a formula you want to learn, derive this sum. Next I need to teach you one important thing here, 6th one. If limit n tends to infinity, see, limit n tends to infinity, n plus 1. What is the meaning for this one? In place of n, I need to apply infinity. Once applying, I should not put this limit. So apply here infinity plus 1. This will become once again infinity. Infinity plus 1 once again becomes infinity. So the infinity is not a proper answer. This is an undefined form. So we need to bring another good answer, or the defined answer. Nothing but limit n tends to infinity, n plus 1. I need to apply infinity in place of n, but how I am going to apply? Next, limit n tends to infinity, take n as common here, take n outside. If I am going to take n outside, I can write 1 plus 1 by n. This is the logic here. You want to learn this this thing is very important for you. This thing is very important for you. Why? If I am going to take in n plus 1, I can't apply infinity, because infinity plus 1 once again become infinity. So take n outside. If I am going to take n outside, if n is moved outside, this will become 1. This will become 1 by n. If I want, you can multiply. N into 1 is n. This n is multiplied, n cancel, answer is 1. So I can write n, if I take n outside, then it becomes 1 plus 1 by n. Then you can apply the infinity. While deriving the sum, this will be very useful for you. Otherwise, limit n tends to infinity, 2n plus 1, limit n tends to infinity, take n outside. If I going to take n outside, the remaining is 2. I taken n outside, there is only 1, no, so I want to put 1 by n. This one you need to learn. Then only the sum while deriving will be very easy. Take n outside, because I can't able to apply infinity. So from this I am going to move towards exercise 9.2 now. Exercise 9.2, first sum, first subdivision. Evaluate the following integrals as the limit of the sums. limit is 0 to 1, upper limit, lower limit and upper limit 5x plus 4 into dx. First, I need to assume this is f of x. Let f of x is equal to 5x plus 4. Next, this one is a. Lower limit is a is 0. Upper limit is b is nothing but 1. Next, write the formula. What is the formula? Integration of a to b f of x into dx is equal to limit n tends to infinity b minus a by n. B minus a by n. Sigma or summation r equal to 1 to n. F of a plus b minus a by n into r. Close the bracket. If you once write this formula, you can easily solve this sum. First, in this formula, I am not going to apply the value at straightly. I am going to divide the value which I am going to apply. B minus a by n. First, I will find b minus a by n. What is the b value here? 1 minus. What is a value? 0. N. Write n as it is. Write n as it is. 1 minus 0 is 1. 1 by n. Therefore, b minus a by n value is 1 by n. Next, I am going to find this value. I am going to find this value. What is value? F of, open the bracket, a plus b minus a by n into r, close the bracket, is equal to f of. What is the a value? A value we know. A value is nothing but 0. A value is no 0 plus b minus a by n. B minus a by n value is 1 by n. 1 by n into r, close the bracket, is equal to f of 0 plus 1 by n. You can write as 1 into r. You can write as r by n because 0 is nothing, no. So you don't need to add anything. F of 1 into r is r. F of r by n. You know the formula. What is the formula? What is we have assumed f of x? F of x we have assumed nothing but 5x plus 4. But I need f of r by n. F of r by n in place of x. Listen carefully. In place of x, I need to apply r by n. In place of x, I need to apply r by n. So how I can apply 5 in place of x, apply r by n. R by n plus 4. Therefore, what is the answer? 5 into r by n plus 4. This is very, very important thing. Because we know f of x is equal to 5x plus 4, but what I got f of r by n. You know f of x is equal to 5x plus 4 means I need f of r by n. In place of x, I need to apply r by n. In place of x, apply r by n. 5 into r by n plus 4. So this is the value we have generated from this year. So now apply integration of a to b. What is a to b? A to b is nothing but 0 to 1. F of x. What is f of x? 5x plus 4. 5x plus 4 into dx is equal to limit n tends to infinity. Limit n tends to infinity. B minus a by n. B minus a by n is nothing but 1 by n. Sigma or summation r is equal to 1 to n. We have found f of a plus b minus a by n. R is nothing but, open the bracket and write 5 r by n plus 4. 5 r by n plus 4. So now multiply this sigma or summation with each and every one. Okay, multiply is equal to limit n tends to infinity 1 by n. So I put bracket like this. So sigma or summation r equal to 1 to n 5 r by n plus, multiply with this, sigma or summation r equal to 1 to n into 4. I think you can easily understand this. This sigma is multiplied with this one. This sigma is multiplied with 4. Okay. After multiplying, you need to be very careful. 1 by n. 1 by n. This 5 by n I can move outside. This 5 by n I can, because I need only r. We have C formula for only r, no. This 5 by n is moved outside. Sigma r equal to 1 to n, only r should be stand. Because we have formula for only sigma r equal to 1 to n, r square, r cube and constant. These 4 should be present inside a sigma. The remaining should be moved outside. Either constant r square or r cube. This 4 should be present inside the sigma. The remaining anything you can be moved outside. The same. So 5 by n can be moved outside, only r should be present. So same here also. See, constant. So what I can write? I can write as 4n. I have told one formula. Sigma of constant I can write as 4 sigma constant into n, nothing but here 4n. So equal to limit n tends to infinity 1 by n. Limit n tends to infinity 1 by n. 1 by n, 5 by n. This is a formula. What is the formula? N into n plus 1 by 2 plus 4n. This n we can cancel. So remaining is nothing but limit n tends to infinity. Still I not apply the limit. N tends to infinity 1 by n. 1 by n, open the bracket, 5 by 2. 5 by 2 n plus 1. 5 by 2 n plus 1 plus 4n. So now I am going to multiply the limit with this one and with this one. So how are we going to multiply? Okay, after applying limit n tends to infinity 1 by n, limit n tends to infinity 1 by n, this is a multiple value 5 by 2 n plus 1, this is a multiple value 4n. So okay, see, I have multiplied limit n tends to infinity 1 by n, limit n tends to infinity 1 by n, I have multiplied 5 by 2 n plus 1 and 4n. If I want to apply limit here, infinity plus 1 once again be infinity. So this n can be cancelled. N can be n cancelled, no problem here. But here, if I going to apply limit here, limit n to infinity, infinity plus 1 is infinity, 5 by 2 is infinity, all the things will become infinity. So here I need to take n outside. That one I teach you. Limit n tends to infinity 1 by n, 5 by 2, take limit outside. If I take it limit outside, the remaining is this n moved outside, 1 plus, this will become 1 by n plus limit n tends to infinity, the remaining thing is nothing but 4. Now n and n can be cancelled. So see here, limit n tends to infinity 5 by 2, 1 plus 1 by n plus limit n tends to infinity 4. I want to teach you one thing. See here, if limit n tends to infinity, listen carefully, 1 plus 1 by n, I am going to apply in place of n, I need to apply infinity. 1 plus 1 by infinity. Once I have applied, I should not put limit once again here. That's all. Once I have applied, I should not put limit here. So 1 plus 1 divided by this infinity, I can write as 1 by 0. This infinity, I can write 1 by 0. This 0 can be moved upward. 1 plus 0 into 1 by 0. 0 into 1 by 1. This is 1, no, 1. 1 plus 0 into 1 is 0 by 1, nothing but 1 plus 0 by 1 is 0. 0 by 1 is 0, nothing but 1. If I going to apply, this is very, very important, 1 plus 1 by n, if I going to apply infinity in n, this will become 0. I get one answer as 1. This only you need to learn here. This only you need to learn more here. Once again saying, simple words, limit n tends to infinity, 1 plus 1 by n means, if I going to apply infinity here, 1 plus 1 by infinity, this will become 0. 1 plus 0 is nothing but 1. Suppose here 2 is present, answer is 2. That's all. You can change it like this. Okay. So I am going to apply limit here. 5 by 2, right, as it is 5 by 2. I am going to apply infinity here. Once I apply infinity, I can remove this limit. So 1 plus 1 by infinity, I can write as 0 plus. There is no n value at all. If there is n, I can apply infinity. There is no n value at all. So write as it is 4. So 5 by 2, this will become 1 plus 4 is nothing but 5 by 2 plus 4 is equal to cross multiply 5. 2 4s are 8 by 2. Nothing but 5 plus 8 is 13. 13 by 2. 13 by 2 is a required answer for this sum. From this, we are finishing this sum. Thank you.